When you think of the Big Bang Theory, what comes to mind? An explosion that created the universe, right? But did you know the person behind this groundbreaking idea wasn't just a physicist, but also a Catholic priest? Let's look into the incredible story of Georges Lemaitre and how he revolutionized our understanding of the universe. This is the story of the man who saw the universe in a new light. Georges Lemaitre was born in 1894 in Charleroi, Belgium, a small town known for its coal mining. From a young age, he showed a keen interest in both science and faith. This dual passion would shape his entire life. Lemaitre studied engineering, but after serving in World War I, he shifted his focus to physics and eventually entered the priesthood. Ordained as a Catholic priest in 1923, Lemaitre had a unique mission to bridge the gap between science and religion. He believed that studying the universe was a way to get closer to understanding God's creation. But it wasn't just faith that guided him. It was also a love of mathematics and theoretical physics. Lemaitre's groundbreaking ideas would eventually lead to the formulation of the Big Bang Theory, forever changing our understanding of the universe. His work earned him recognition from some of the greatest minds of his time, including Albert Einstein. Lemaitre's contributions to science and his efforts to harmonize it with faith left an enduring legacy. At the time, Albert Einstein had just introduced his general theory of relativity in 1915, which showed that space and time were interconnected and could change due to the presence of mass and energy. However, Einstein and many others believed the universe was static, neither expanding nor contracting. But Georges Lemaitre thought differently. In 1927, while working on his PhD, he applied Einstein's equations to the entire universe and concluded that it must be expanding. He proposed that if the universe was expanding, then it must have been smaller in the past, much smaller in fact. Lemaitre hypothesized that the universe began as a single, incredibly dense point, which he called the primeval atom. From this, everything expanded outward. This was the birth of what we now call the Big Bang Theory. Initially, Einstein was skeptical of Lemaitre's ideas, famously remarking that his calculations were correct, but his physics was abominable. However, over time, observational evidence began to support Lemaitre's theory, leading to a paradigm shift in our understanding of the universe. Today, the Big Bang Theory is a cornerstone of cosmology, explaining the origins and evolution of the universe. Lemaitre's groundbreaking work laid the foundation for modern cosmology, forever changing our view of the cosmos. When Lemaitre first published his idea in a scientific journal, it didn't gain much attention. But 2 years later, in 1929, Edwin Hubble made a groundbreaking discovery. By observing distant galaxies, Hubble found that they were moving away from us and their speed increased with their distance. This was the observational proof that the universe was expanding, exactly what Lemaitre's calculations had predicted. Lemaitre's bold presentation had finally been validated. His work laid the foundation for modern cosmology. In 1933, Lemaitre presented his revolutionary idea to Albert Einstein himself. Initially, Einstein was skeptical. But after witnessing Lemaitre's compelling presentation, Einstein reportedly said, "This is the most beautiful and satisfactory explanation of creation I have ever heard." A high compliment from the world's greatest physicist. This moment marked a turning point in the acceptance of the Big Bang Theory. Lemaitre's work laid the foundation for modern cosmology, and his meeting with Einstein was a pivotal moment in the history of science. Despite Lemaitre's success, not everyone agreed with him. In 1949, British astronomer Fred Hoyle, who supported an alternative idea called the steady-state theory, coined the term Big Bang. Ironically, he meant it as a joke, dismissing the concept as overly simplistic. But the name stuck, and so did Lemaitre's theory. Over time, the Big Bang Theory gained more acceptance, reshaping our understanding of the cosmos. Today it stands as one of the most significant scientific theories explaining the origins of our universe. The final nail in the coffin for competing theories came in 1965, decades after Lemaitre first proposed his revolutionary idea. Arno Penzias and Robert Wilson, two physicists working at Bell Labs, stumbled upon something extraordinary while testing a large, horn-shaped antenna designed for satellite communication. They encountered persistent background noise, static, that seemed to come from every direction in the sky, day or night. Despite their best efforts to eliminate possible sources of interference, including cleaning out nesting pigeons and their droppings from the antenna, the noise remained. What Penzias and Wilson had inadvertently discovered was the cosmic microwave background, CMB, the faint afterglow of the Big Bang, a snapshot of the universe when it was just 380,000 years old. This radiation, stretched to microwave wavelengths as the universe expanded, provided the long-sought evidence that the cosmos had a definite beginning. It was the smoking gun that confirmed Georges Lemaitre's Big Bang model, vindicating decades of theoretical work. This wasn't just a scientific breakthrough. It was a moment that changed our understanding of the universe forever. The CMB proved that the universe was dynamic, evolving, and much older than anyone had previously imagined. While Lemaitre himself had passed away in 1966, just 1 year after this discovery, his legacy was cemented as the father of modern cosmology. But the Big Bang theory was not the first time a revolutionary discovery upended humanity's view of the cosmos. To understand the weight of this moment, we must travel back over 4 centuries to another transformative figure, Nicholas Copernicus. In 1543, Copernicus, a devout Christian mathematician and astronomer, published his groundbreaking work De Revolutionibus Orbium Coelestium, on the revolutions of the celestial spheres. This book challenged the widely accepted geocentric model, which held that the Earth was the center of the universe and all celestial bodies revolved around it. For over 1,000 years, this model had dominated Western thought, largely because it aligned with theological interpretations that placed humanity at the center of God's creation. Copernicus, however, dared to propose a radical alternative, the heliocentric model, in which the Earth and other planets orbited the Sun. His ideas, while rooted in observation and mathematics, were not merely scientific. They had profound philosophical and theological implications. If Earth was not the center of the universe, where did humanity stand in the grand scheme of creation? Copernicus himself wrestled with the religious and societal consequences of his theory. He delayed publication of his work for years, fearing backlash from the church and scholars who clung to the geocentric worldview. Yet his faith in a rational and orderly creator drove his curiosity. He believed that the universe was not chaotic but governed by divine laws that could be understood through reason and observation. For Copernicus, uncovering these truths was an act of devotion, a way to glorify God by studying the magnificent design of his creation. The heliocentric model didn't gain immediate acceptance. It faced fierce resistance from theologians, philosophers, and even scientists of the time. Yet much like Lemaitre's Big Bang theory, Copernicus's ideas laid the foundation for future breakthroughs. Galileo Galilei, Johannes Kepler, and Isaac Newton would later expand upon his work, further dismantling the geocentric model and replacing it with a vision of the universe as a vast, dynamic system governed by natural laws. The parallels between Lemaitre and Copernicus are striking. Both were deeply religious men whose discoveries challenged humanity's place in the cosmos. Both faced skepticism and resistance, yet their work ultimately transformed our understanding of the universe. In both cases, their faith did not hinder their scientific pursuits, but rather inspired them, providing a framework for exploring the natural world as a reflection of divine order. As we look back on these monumental discoveries, it's clear that the quest to understand the universe is a timeless journey. Whether through the faint whispers of the cosmic microwave background or the mathematical elegance of planetary orbits, these revelations remind us that science and faith, far from being in conflict, often converge in the pursuit of truth. Today, the Big Bang theory is widely accepted as the best explanation for the origin of the universe. Georges Lemaitre's work not only transformed our understanding of cosmology, but also proved that science and faith can coexist. For Lemaitre, Studying the universe wasn't just about equations and observations, it was about uncovering the story of creation itself. His legacy continues to inspire scientists and theologians alike, bridging the gap between the empirical and the spiritual. Lemaitre's vision of the universe as a dynamic, evolving entity remains a cornerstone of modern cosmology. So next time you look up at the stars, remember the Belgian priest who dared to challenge the status quo and showed us how the universe began. Georges Lemaitre, scientist, priest and visionary, proved that sometimes the most groundbreaking ideas come from the most unexpected places. Subscribe for more stories about the fascinating people behind science and discovery. And remember, the universe is full of wonders waiting to be discovered. Keep exploring, keep questioning, and keep looking up.